Hey, what's up guys? Andrew here with Tate Tech. Today we're going to be talking about how to build your own hot swappable mechanical keyboard. And the best part, you don't need to learn how to solder or even screw anything together. Now, before I get to show off my beautiful custom keyboard, it would probably help to understand how the thing even works. Before we get into the meat of the keyboard, let's talk about what you see at first glance. This is a keycap. Despite what many people think, in a mechanical keyboard, the keys you type on are not just one piece, but instead are both a switch and a keycap stuck together. Now, we'll explore switches in just a moment, but for now, let's talk about why you may want to pay attention to the keycap that you choose. Firstly, not all keycaps are compatible with all switches, so you'll want to make sure to do your research before making any purchasing decisions and select keycaps that will fit your build. Secondly, there are many different angles and curves to switches. Let's say you prefer the flat chiclet style of most laptops. Well, you can buy flat keycaps. If you hate how those feel and you prefer keycaps that have some curves and cradle your fingers, well, hey, it's your world and you can have it your way. Lastly, bling, people. One of the most compelling reasons to go through the pain of building your own keyboard is that you can exercise your creativity and make it look however you'd like. There are even companies that will make metal keycaps just if you want to flex. Again, it's your world and you have the power here. Now, let's talk about switches. These little babies are arguably the most important part of your build. The switches will sit between the keycaps and the PCB and provide much of the haptic feedback and resistance for the keyboard. The bulk of people building their own keyboards do so to have complete control over the switches that are being used. There are many different types of switches with many different designs, all of which have their pros and cons. For instance, my favorite switches are the Cherry MX Blues. They are extremely loud and very clicky. They're designed this way on purpose, and many people love them for these qualities. That being said, my girlfriend is not one of those people. So, to reduce noise, I got one of these little guys. What you're looking at here is a Cherry MX Silent Red, otherwise known as a Cherry MX Pink. RGB variant, of course, so we can have all that nice RGB blingy goodness. These are what are known as linear switches, and are designed to give very little resistance. Another bonus here is that they're designed to reduce noise and clickiness, so they're perfect if you want a mechanical keyboard, but don't want to infuriate your office mates, or, like in my case, your significant other. To give you a better understanding of switches in general, let's run down the various qualities they can possess. Firstly, there are three major types of switches: linear, tactile, and clicky. Linear switches are designed to have an extremely smooth travel and provide no feedback that the key has been clicked. This type of switch allows for quicker actuation, thus is far and away the preferred switch type for gamers, both pro and amateur. Tactile switches take a much different approach, and instead are designed to give you noticeable feedback when the key is pressed. When pressing down on a key with a tactile switch, you'll feel a bump about midway through the key travel to indicate that the switch has been actuated. Finally, there are clicky switches. These are not much different than tactile switches, other than that they provide a very audible click when they are actuated. These are personally my favorite type of switch. My entry into mechanical keyboards was with the Cherry MX Blues, so they hold a special place in my heart. But this type of switch is also considered the most annoying because they are, and I can vouch here, extremely loud. The next characteristic of switches are the actuation point and actuation force. The actuation point of a switch is simply the point at which the key registers a button press, and this is generally measured in millimeters. This is yet another very important thing to consider when building a keyboard. There are some switches, albeit quite rare, that can be actuated by simply brushing them, and some that need to be bottomed out or pressed all the way down before they become actuated. To make things even more complicated, in addition to the actuation point, there's also an actuation force, which is the amount of pressure that needs to be applied to the key in order to actuate it. You can have something like the silent reds, which require only 45 grams of force and are the ones that I use, to the MX greens, which require almost double the force at 70 grams. The last pieces of our keyboard here will be the PCB and the case. The PCB can be thought of as the brains of the keyboard and contains the firmware that will interpret the key presses and translate these into your computer. Now, under normal circumstances, you would need to buy a case separately, solder the keys to the PCB, screw the PCB into the case, install a battery if it's Bluetooth compatible, and then screw in the faceplate. But if you recall, I mentioned we would not need to do any soldering, and that's where this special little guy comes in. This is a CNC cut wooden case with the PCB, battery, and faceplate pre-installed, taking out much of the manual work. What is really special here is the PCB that is being used inside. The case contains inside of it a GK64S. The reason this is special is that it comes with hot swappable terminals pre-soldered into the board. What this means is that all you need to do is simply press your switches into the PCB to install them. Another bonus here is that this particular board comes with Bluetooth and wired capability, as well as being pre-programmed. While programming a keyboard is not difficult, this is certainly nice that we're dealing with a mostly plug-and-play solution here. With all your newfound keyboard knowledge, let's dive into it. Let's take a look at how easy it is to build a keyboard and swap the components whenever you want. Now, we mentioned that all you need to do to actually install a switch is to press it into the actual keyboard. So that's what we're going to do. If we look in here, you'll actually see 3 little holes. One little hole will correspond to the big bump on the back of the key switch and will serve to kind of hold it in there and stabilize it. The 2 smaller little holes will actually coincide with these 2 little metal stubs or prongs sticking out of the key switch. Now, normally, this is where you would take solder, you would go in behind the board, you would put these through and then solder them together to complete the circuit. Well, with these hot swap switches, we don't have to do that. These terminals already take care of all of that inside of them, so we just need to pop these guys in. So it is as simple as just taking it and making sure that they're lined up, because these are fragile, they will bend. So I'm going to put this down here. We're just going to make sure that all of those holes line up. It should just fall right in. And then we're just going to press it down. That's it. So why don't I go ahead and install the rest of these really quickly. Now, what we're left with here is a keyboard. You know, imagine that these keys aren't here, we're installing it fresh. It is a keyboard with a bunch of switches installed, but no keycaps. Now, typing directly on switches, probably not what you want, and I can guarantee you is not very comfortable. So we want to install keycaps. Now, this is just as easy as installing the switches. Really, all you have to do is take them and press them on to the switch that they need to be installed on. Now, if you're confused and you can't remember the layout of a keyboard, that's fine. What you're looking for here is a 60% keyboard layout with arrow keys. Now, 60% keyboards, such as the GK64 and GK64S, can come with arrow keys or no arrow keys. This will change the layout. So simply go on your favorite search engine and search, 60% keyboard layout with arrow keys, or GK64S layout. In Google Images or Yahoo Images, whatever you'd like, it'll come up with what you need. So once you have the layout, you just go ahead and pop these in. There's a little cross inside of these keycaps that correspond with the cross design on the MX switches. So all I'm going to do is take this and press it on there, and all of a sudden, it's stuck on, it ain't coming off, and we have a functional key. So I'm going to go ahead and install the rest of these. I'll be back in just a second. It really is that easy to build your own keyboard. Now, let's take a look at the finished product a little bit closer. Well, this was a really fun experiment, and I love the new keyboard. It's important to note that there are some cons here. First of all, if all you want is a reliable keyboard with switches of your choice, you can likely find a pre-built keyboard at a much lower price point. Additionally, sourcing the switches for this build was particularly difficult at a decent price. I ended up having to participate in a group buy from Shenzhen, China, that took about a month to arrive and didn't have the best shipment tracking. Another thing to note here is that the keyboard we built was a 60% keyboard, which does not include the F keys, nor does it have a number pad. Additionally, while the GK64S does have arrow keys, you have to be careful with the 60% boards, as many of them do not have these keys, and often have shorter special keys, such as a shorter right shift, control, and alt. When building custom keyboards, these 60% boards are by far the most common, and finding hot swappable PCBs at other sizes proved extremely difficult. That being said, if you want to learn to solder, your options here are much more plentiful. Well guys, that's it for this video. If you want to know the exact parts I used in my build, you can find those in the video description below, as well as if you enjoyed this video, please consider liking, subscribing, and commenting. You can also follow Tate Tech on Instagram and Twitter. If you ever wonder how cloud gaming works, you can also check that out above. Until next time,